Hello students, I'm Dr. Z and I volunteer with the Children's Science Center. This is one of your do-it-yourself series, and today we're going to talk a little bit about electromagnets. Electromagnets are important really because they're everywhere in our lives, in our homes, washers, dryers, computers, telephones, in our automobiles, they're just everywhere. So before we really get into them, let's review a little bit about magnets themselves. And as you may recall, there are basically two kinds. One is called a permanent magnet and the other is a temporary magnet. This is an example of a permanent magnet. There are actually three of them stacked together. This is called a neodymium. I bought this on Amazon. It's a pretty strong magnet. And this will always be a magnet. It never will wear out, or not for thousands of years. So that's a permanent magnet. The other kind of magnet is called a temporary one, and let's demonstrate that a little bit. I have a steel nail here, and as you all know, iron or steel, especially iron, is attracted to magnets, and you can see that here. I have a paper clip, and the paper clip also has iron in it, so as you can see, it's attracted to the iron nail, and I can even put a few more paper clips on there. But as soon as I remove the nail from the permanent magnet, after a few seconds, the nail loses its magnetic property, and as you can see, I can no longer get the nail. So that became a temporary magnet for less than a minute by putting it in contact with a strong permanent magnet. So temporary, permanent. Now there's a special kind of temporary magnet called an electromagnet. And I have an example of that here that I made, and it's something you can think about doing at home. And what I've simply done here is I've taken an iron nail, okay, and we know that iron is attracted to a magnet. And then I took copper wire and I wound it around the nail maybe 100 times, 100 winds, okay? And then I took the two ends of the wire, the one here and one here, at the bottom and the top, and I connected it to two batteries that I have here. Again, as you can see, I got these at Amazon. And you can also buy these little boxes that have a very convenient switch. So I can switch the batteries on and I can switch the batteries off, okay? So we have our iron nail, we've wound copper wire, and you have to make sure that it is real copper, and then connected to a battery source. So as we know, iron is attracted to magnets, but copper is not, okay? So copper is not attracted to magnets. So as you can see here, the iron nail with the copper wound around it is in no way a magnet. But let's turn the batteries on now. And now we have electricity flowing through the wire all the way around my coil and then out again and back into the battery. So we have a flow of electricity through this copper coil. Now lo and behold, it is now a magnet. See that? I don't know if it's strong enough, if I can, no, it's not quite strong enough. Will it hold two of us? Whoops. No. Anyway, it will hold this big one up like that. So it's not not real strong, but it is a magnet. Now, if I turn the electricity off, it immediately is not a magnet anymore. So let's try that again. It's not a magnet. If I turn it on, it's now magnetic. When I turn it off, it's not a magnet. So the wonderful thing about these temporary magnets, and especially electromagnets, is that we can turn them on and we can turn them off at will. And the reason this is working is that when the electricity flows through that copper wire, about 200 years ago, scientists discovered that when electricity is running through a conductive wire like this, it produces its own magnetic field. And this was the beginning of the understanding of electromagnetism, okay? So anytime that you have a copper wire with electricity running through it, it creates a magnetic field. And in this case where we have the iron nail here, the magnetic properties were transferred from the copper wire to the iron nail, and that became a magnet. And these electromagnets are used, like I said, in a lot of things, and even in electric motors. And that's something maybe we'll look at in another video very soon. Okay, thanks guys. Keep loving science the way I do, and we'll see you soon, maybe at the Science Center.